Okay, 35.5, the last videos. So this one we're going to learn the special equation using the enthalpy change of combustions to help us to do the math. So the special equation, just like the previous videos, okay, the condition to use this, okay, we need a target equation. The target equation this time, okay, it will be a non-combustion equation. Okay, any non-combustion equation will be all right. Say, for example, if you have formation, that will be all right. If you have just a reaction, that will be all right. And also, okay, the question will give you tons of standard enthalpy change of combustions here. So I'll just see these two examples. So we have a non-combustion equation. So this have to be the target equation. And then after that, you will have the combustion, okay, combustion of C2H4, combustion of ethanol in this case. Okay, while the other examples you can see here will have like combustion for graphite, hydrogen, and also methane. And the target equation that you're looking for, okay, that will be the formation of methane. Okay, so it would be like that. So how to use this one, okay? So periodically, okay, when we have one equation written like that, okay, hydrogen sulfur, okay, and then they react together to form hydrogen sulfide. So if these chemicals are able to be combust, okay, we burn the hydrogen and burn the sulfur, they will turn into water and also sulfur dioxide. That will be the same for the product. Okay, when we have hydrogen sulfide here, when we burn them, they will also give these two products. So you see that these times, okay, when we burn this, okay, they will give the common products in the process. Okay, so by using Heck's law, you find the green arrow, all these things together, delta H plus the combustion of hydrogen sulfide will equals to the combustion, standard enthalpy change of combustion of hydrogen and also sulfur here. So you will have equation like this. So see clearly, for this one, that will be the product, but for this one, that will be the reactant. Again, the product and reactant, it depends on the target equation. The target equation here, okay, the reactant is H2 and S, so therefore we will say this one will be the reactant. When we rearrange this equation, the product, put it this way, okay, then we will have the delta H equals to R minus P. Okay, so that will be different from the previous equation, that is P minus R, okay? So in general, the enthalpy change cycle will be like this, okay? The reactant to give these products, and both reactants and products, okay, can be burned, okay, to give the same combustion products, okay? So if we put it in a Heck's law equations, then that will be delta H plus the summation of the products equals to summation of reactant. After rearrange, we put the reactant on, we put the products to the other side, that will be reactant minus products. That will be the equation that we're using today. Okay, so our last video we mentioned, okay, we are dealing with combustion C. Okay, so therefore delta H equals to R minus P. Okay, C is a short one. Okay, so I will start with short. Okay, R come first. Let's have a look how to use. So right now, check the equation, which equation you're going to use. So we have combustion, 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 and then you have a target equation. So this one will be the reactant, this one will be the product. So according to the Heck's law equation, delta H equals to summation HC of the reactants minus summation delta HC of the products. Okay, so here, remember this equation, no need to write. Okay, no need to write. Okay, too complicated. Okay, but you have to know how to put it into, put the values into it. Okay, the reactants we have H2 and S. So therefore H2, which will be negative 285.8 with one H2 only. Okay, and then we have S. Okay, that will be negative 296.8. Okay, so this one will minus, okay, H2S, which is negative 563 for here. Okay, so by rearranging the numbers, okay, then you will find that delta H will equals to negative 19.6 kilojoule per mole. Okay, again, actually you can construct enthalpy change cycle, but by doing that, okay, you may need to express okay, all these things into equation, okay. For combustion of sulfur, then you have to add it, become SO2, then you will just do a lot of work in it, okay. So remember, all of them are combustion and one target equation, then we'll use R minus P to help. So one more time. So this one I will have like combustion, okay, and then we have a target equation here, okay, target equation. So this would be the reactant, this would be the product. So delta H equals to reactant, okay, that will be negative 1299, okay, plus, okay, and then with H2 with negative 285.8, but this time we have 2 here, so therefore remember, multiply this one by 2, okay, and then minus product, okay, product will be C2H6, okay, that will be negative 1560, okay. So by solving the equations, okay, you have like 310.6 kilojoule per mole, okay. So for this equation, can we use delta H equals to P minus R, or delta H R minus P? Remember, P minus R, a long one, so this one is having a lot of formation, so this one having a lot of combustion. Can we use this equation to help? Okay, so you can check. This formation? Seems that it is not. Okay, this one is formation, but these are not formation. Okay, are these combustion? It's hard to tell. So you'll find that in these questions, okay, not likely we'll be able to use these two equations. So you have to get back to either you use cycle or you use statement to help you. Okay, so how about these two? Okay, so question number 2. Okay, you have combustion, and then, okay, you have to find the enthalpy change of formation of 100 gram. Okay, so that means that right now, okay, you should have a formation. That will be a target equation, but it is not written out. So therefore, the first things you have to do is to write the formation equation first, and then you'll be able to find out the standard enthalpy change, okay, of this reaction. But remember, okay, I'm giving you 100 gram, so you'll find that this time the enthalpy change that you're going to find ultimately should not be kilojoule per mole, okay, because you have to convert 100 gram to, okay, divided by mm to number of mole, and then, okay, you're going to multiply this one, so you will be expecting this enthalpy change should be talking about kilojoule. I know that many of you feel confused. You don't know when will be kilojoule per mole, when will be kilojoule. But in public exam, most of the time they will be giving you a values, okay, a unit, okay. Say for example, to determine the enthalpy change in kilojoule, okay, and then that would know that, okay, that would be purely kilojoule. But if you say that, okay, enthalpy change of formation in kilojoule per mole, then you know that, okay. But sometimes if you really don't have this kind of information, then you have to read the questions carefully to feel that this enthalpy change is talking about per mole or not, okay. If you have like standard enthalpy change or blah 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 things like that, normally that would be per mole. But if you just say, oh, determine the enthalpy change of some things, okay, and they give you the mass of that chemicals, most likely that will be in kilojoule, okay. So question number 3, you'll find that, okay, this time we have formation, combustion, and then we have a target equation. Whoa. So obviously this one, okay, it doesn't have purely combustion plus one target or purely formation plus one target. So it seems that you are not able to write or to use the equation just how we taught. But if you take a closer look, you'll find something very interesting. For example, for combustion of H2, if you write it into a equation, that will be something like this. If you pay attention to that, actually, this equation can also say it as delta H formation of H2O. Okay, so actually this combustion we can bring in at formation of H2O. And then combustion of carbon, okay, carbon, they will form CO2. So for this one, actually you can say it as formation of CO2. Okay, remember you have the bracket here. Okay, so actually if you do it like that way, then you see that 4 of the equation, all of them are formation, 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 and you have one target equation. So if you can see this, actually you can use the equation as well, because you got the target equation, you have the reactant, and you got the product. And if this is a formation, it will be P minus R. So you just have all the formation of this add up together minus the formation of this, then that will be the answer. Okay, but if you can't see that, okay, you just express them into equation, because it doesn't fall into any special equation that you can use. Then you have to put these into a equation, and then afterward you either use cycle or use statement to help yourself to do that. So when to use enthalpy change cycle? Okay, as long as you feel comfortable all the time, okay, you can use enthalpy change cycle, but sometimes it will be very, very slow. Okay, statement form, okay, all the time as well, except if they request you to write enthalpy change cycle, then at that time you will be forced to use enthalpy change cycle. Okay, special equation, okay, if you are talking about giving a lot of formation, then okay, the equation that you use is H, delta H equals to summation of P minus summation of R. I just simplify it. F, okay, P minus R, okay, C, R minus P, okay. Remember, when can we use this equation? Only if you got a target equation plus, for the one formation, you have many formation. For the combustion, you have many combustion. Okay, so recognize those kind of equations, okay, are those kind of questions that can be used this special equation, because it can help you save a lot of time. So final reminders on the thermochemical equation. Remember, when you write thermochemical equation, you must state the state. That means H2O have to be liquid state, H2O have to be gas state. Then it will affect the enthalpy change by a lot. Okay, remember, after the equation you have to write down the delta H at the back, and also you have to put positive or negative sign. Okay, that one will be very important. And for the target equation, the coefficient have to be 1. What is a target equation? Say for example you talk about formation of say for example H2O, then maybe H2O, this one have to be 1, okay, and then H2 plus half O2, okay, so this one have to be 1. Okay, if you talk about for combustion, okay, say for example you're burning CH4, then for CH4 this one have to be 1, okay, and then they give the CO2 and H2, things like that. Okay, so the one that I want to remind you is 5. Okay, sometimes some same equation, they may have different names. Okay, just like I showed you already. Say for example formation of water. Okay, when you have say H2 plus half O2 to give H2O, you may say that this is formation of water, or you can say that it is a combustion of hydrogen. That would be all right. Same thing happen, go to nitrogen dioxide. So when you have nitrogen dioxide, okay, you burn it. Oh, this one would be slightly different. Okay, formation of nitrogen dioxide. Okay, if you say formation of nitrogen dioxide, this one have to be 1. Okay, but for combustion of nitrogen, then this one, okay, the N2, this one have to be 1. Okay, so in this case, okay, maybe slightly different. Okay, but anyway, okay, some of the equation even they have same equation, they may have different name. You have to pay attention to that. If you can spot it out, okay, that will be very helpful in helping you to solve the question. So summary, okay, you have to know that, okay, formation, give you a lot of formation, that will be P minus R, long, okay. If it is combustion, that is a short one, that will be R minus P. Okay, combustion, R, short, okay. So just help you to memorize these two equations. Okay, so our reminders on thermochemical equation. just 0.5 is extremely important, okay, because some of the questions in the MC, they will give you an equation and ask you, what is the name of this equation, okay? So at that time, remember, one equation may not only having one name only, they may have more than one. Okay, so that's all for this videos, and also this is the last videos for the whole section, okay, about energetics. So times to finish your notes and also the chapter exercise. Okay, you need a lot of practice. Okay, I will give you the past paper very soon as well, so please spend time on that. That's all. Bye bye.